Let's look at how to get the attributes of an array. So let's say, so again, we obviously start with importing Numpy. If you have already done it, you don't need to do it again. So this, right, this is again that numpy.random function that we're using. It has these methods. Now the seed method, we might use this later on, is used for reproducibility, which means that if you fix this number, then the random numbers that are generated, the distribution that is generated, is always the same. So so we'll see that this is really useful later on when we are dealing with machine learning models, and we want to basically test our model. But if the random numbers keep on changing, then the accuracy keeps on changing as well. It has a variation, slight variation. So if you don't want that and you want reproducibility, you can set a seed that always gives you the same set of random numbers. Now here what I'm doing is we're gonna generate different dimensions, right, just to illustrate some indexing and slicing. So here we have a 1D array, right? This is again an array from of numbers from 0 to 9, but we have different sizes over here. This is a size 6 array. This is going to be a one-dimensional array with 6 elements, and this is going to be again, now we're going to change the size. We're going to make it a 2D array. So this is going to be 3 by 4 array, 3 rows, 4 columns, and it's again going to have numbers between 0 and 9, and this is going to be a higher dimensional, even higher dimensional array. So this is going to be 3 by 4 by 5, right? So this is like the XYZ dimensions. So so we can get the dimensions of the array using some methods, the attributes of an array. So this is going to give you the dimensions of the array. So x3, we're focusing on x3. You can go ahead and try these same things with x1 and x2. X dot n dim, right, the number of dimensions, that this is what it means. It's going to give you 3. So x3 you can see has is a 3-dimensional array, right? So don't confuse the number of dimensions with this, with the shape. If you want the shape like 3 by 4 by 5, you have to use the dot shape method. So that is going to give you 3 by 4 by 5, and the size is going to be, so this, if you multiply the two together, right, so 3 multiplied by 4 is 12, and 12 by 5 multiplied by 5 is 60. So that's that means it has 60 elements. Now you can also see the data. By default, the data type is integer. So we didn't, although we did not mention the data type, it's automatically going to change it, choose integer. Now let's look at what is going to be what is going to be x1, right? So we can check that. Let's look at x1. So x1 is just again random numbers between 0 and 9. X1, so again, so this is just going to be like lists. We've been through lists in the first week, lists in Python. So the indexing in Python is going to be, in Numpy, is going to be the same as the general way indexing works in Python. So if you choose, so this can be a review for those of you who are new to Python. So x1 of 0, right? So indexing, for indexing we use these square brackets. So Python always starts with 0 index and then increases by 1. So this gives you 5, right? Because that's the 0th element. 4, so this is 0, 1, 2, 3, 4, so that's going to give you 7, right? Negative, you use negative numbers, you start from the end, right? So this is -1, -2, and so on. So -1 is the last number. This is going to give you the second last number, -2. The index -2 is going to give you the second last number. Now so this is 1D array. X2 is 2D array, right? So now how do you get the indices? How do you index a 2D array? So this is that same array that we started with over here. X2 is a 3 by 4 array random numbers between 0 and 9, and so this is what is that array. You might get a different array because it's well, if you set the seed to be the same, then you should get the same numbers, but if you don't have the seed set to 0, you might get different numbers. So again, the indexing again starts. So this is 0 0 element 0 0, and this is going to be 0 1. It's going to be 0 2 0 3, and this is going to be 1 0. Sorry, 1 1. This is first row and first column. So this is going to be 1 1, and so on. So the numbers, the rows increase this way, the columns the columns increase this way, the rows increase this way. So 0 0 gives you 3, 2 0. Let's clear this up. So you mean by this you mean the second row, right? The second row means obviously in Python this is going to be over here, right? This is row index 0 1 2, right? I'm just writing the row index over here. So this is row 2, right? And then the 0th element of row 2, and that's the 0th column, in other words. So this is row number 2, element number 0. So that's 1, and this is what you get. Okay, so you can also use negative numbers in this case, and the idea is the same. So if you have negative numbers, let's clear this up. You start at the end, right? So this means that you're starting at the. So let's first look at the row. So you're at row 2. So again, this is 0 1 2. You're at row 2, and you want the last element of row 2, right? So that's going to be 7. Right? So that's what you get, 7. And you can also change the value of an element of an array. So over here, what we're doing is we're first choosing x2 of 0 0, which is the first element of the array, and we're setting it equal to 12. So Python or Numpy, they're going to change the array and change 3 to 12. So that's the way you can modify the array. Now let's look at slicing. Slicing again means getting sub arrays, right, from an array. So here let's create a range of numbers from 0 to 9. If you type in 10 again, you get numbers from 0 to 9. The default starting point is 0. Now you can, so again, this works exactly the same way as lists. So there's if you know lists in Python, this is just straightforward. So this means that you want to start with the 0th element, and you want to stop at 4, right? So it never goes to 5. So it's going to give you numbers from 0 to 4. And this means that you want to start at 5 and go till the end, right? And this means 4 to 6, never goes to 7 again. Now this notation in Python is used to skip, right? It's like the step. So this means that you want to start from the beginning, but you want to take a step of 2, right? So it starts from 0 and then 2, 4, 6, 8, right? So this is like a way to skip numbers using indices in Python. Now here also, what this is doing, it's starting from 1, right? Index 1, right? And then it's taking it's basically skipping 2, right? So you can see that it is going to go till the end. So it starts at 1 and then skips takes a step of 2, and then again 2, 5, and then 7, and then 9. And so this is again, these two columns are basically used to skip numbers in Python. Now you can also a short way of, obviously there's an algorithm involved, but this is just notation to perform an operation. So if you want to reverse an array, what you can do is you can use 2 colons and a -1. So that means that you want to basically completely reverse the array that you're working with. And you can combine skipping and slicing also, and reversing also. So so in this case, what you're doing is you're going to start with the element with the index 5, right? And then you're going to skip in the reverse direction, right? So let's go back to that. So you're going to start at 5, right? Can have chosen numbers so that the index and the numbers match. So you can choose any set of numbers. You can also use random numbers. But just to illustrate and makes it easier to understand. So if you use this notation again, 5 and 2 columns -2, the 5 means you're going to start at index 5, and then you're going to take the negative sign means that you're going to go backwards and take a step of 2 in the backward direction. So you get 5, 3, and then 1. And so this is what this is what this array this is what is the array that you get 5, 3, and 1.